Okay, so what I'm going to show you is I don't have any internet right now, but I will show you what the graphing calculator looks like. She's not in there? Okay. So let's see. Let's go to my screen. This is my screen right here, and let's see. Oh, is it? Sorry. Let me move this over a little bit. There we go. I do that all the time in class too. See this thing right here, TI-83. Write this down, because all you have to do is just do a Google search for it. And I mean, if you tell your dad that you're downloading it, for school, um, I haven't had any problems with it. It doesn't have any bugs or anything like that. I don't think it does anymore. It's called TI-83 Plus Flash Debugger. Don't know why they call it debugger, but they do. Okay, I guess Flash because it's a Flash program. If you just Google it, it's a real easy download. It's real quick and easy, and this is what it looks like. So if you open it up, once you get it downloaded, just put it on your desktop, just double click on it, and it'll say this. Now if you go to File and you go to New, or is it New or Open? I think it's New. Yeah. If you go to New, you'll see 3 different styles of calculators here. All right, I just use the TI-83 Plus. All right, the Silver Edition is just like this one. It kind of looks like it's see-through. It's kind of interesting looking. I don't even know what the 73 looks like. But anyway, I always use this one, and this is the one that the guy in the videos uses. All right, and then you'll get this. You're like, where's my calculator? Well, do you see that thing that looks like a play button? Just click on that, and then look at that. A brand new free calculator. And I can only use it on the computer, but if you're around a computer, that's fine. I mean, that calculator costs around $100 or so to buy it brand new. If you want to get rid of this window, don't close it out because it closes the computer. Just minimize it, and then there's your calculator right there. Okay, and yeah, it has been. You're exactly right. Oops, got the wrong thing. It might be a little lower now because there's a lot newer versions of it. But anyway, there you go. So on lesson 16, he's going to go through and show you. It's real basic stuff. It's pretty easy on how to graph with his graphing calculator. Let me show you another. I don't know what I need to do. Let me show you another graphing program. Remember the one I showed you last time? That was that GeoGebra or whatever, and that's a pretty good one. But here's another one it doesn't quite have all the bells and whistles, but excuse me, it's really user friendly. Okay, you know how we had to make all the different graphs, different colors, and had to right click and you had to go through all this stuff. Well, this one, it's gonna pop up. I think it should pop up. I don't know why it's not. Okay, so here's this calculator right here. This is kind of nice. Again, it's called, let me scan that one. It's called G, and then Calc, and then X. And this is like, I think this one is like the newest version of it. I mean, I don't know. It's pretty basic. It doesn't do a lot of things. It doesn't tell you each point, but, I should have brought my mouse, because it'll zoom in and out just with a scroll of the mouse. Let's see if it, well, if I had the mouse, let's see, how do I scroll in and out without the mouse? I don't know. Okay, resume again. So now I have a mouse. So watch, all I got to do is scroll in and out, and look, see, it gets wider like that, okay, or it gets zoomed in and closer up. It's pretty cool. See how it goes by twos? You could always change those right here. You can change that to a 1 and change that to a 1, and then well, thought I'd change it to a 1. Why isn't it doing it? I don't know why. The X gap is 1. Well, anyway, I have to mess around with it. But it is really nice. It already starts with a y. It says y of x, but it's y equals. So, like if you did like 3x squared, you still do that up thing for squared plus 2. Oops. Plus 2. Let's go plus 4. Alright, so if I wanted to graph something like that, I just hit it, and then there you go. And you just kind of move it around. You can just move it around and you can kind of see your graph. You can blow it up, make it a little bit bigger. You can zoom out like this. Okay, you can see where your intercepts are and all that kind of stuff. All right, so that really is nice. So he is going to have you on these videos graphing stuff on a calculator a lot. So you can use the regular calculator like this, which is, it's okay. But as you can see, your screen's a lot smaller. It's not near as clear, right? When they do these curves right here, it's real pixelated looking. It's just not super, super clear. So if you really want to graph, and you want to see what your graphs look like, I would go to one of these other graphs that I've shown you. Okay, so I think that's pretty helpful. All right? So now let's go for some questions that you have on some of the homework. So what do you got? You said lesson 14 was your major, Jacob? Mm-hmm. All right. Well, let's start there, and then if you guys have any other questions, we can do that. So, like, which particular question? Yeah, 12 to 15 are the lessons we had. So we'll do problem set 14. See what are some. You want to do just one of the practice problems, or you want to do 11? Okay.
I'm having trouble with the divide.
The divide? Okay, that's good. I'm glad you asked that because, yeah, I want to show you. You can do it that way, and I've taught that way a lot with that long division. I'm going to show you a little easier way to do it. It's called synthetic division. Have you ever heard of that? Did you do that in Algebra 2? I don't know if you remember that or not. Okay, they call it synthetic division. So here's the problem. Let me write the problem out exactly the way that they write it out, and then I'm going to show you. And it's a little bit easier. You're basically doing the same thing, but you get rid of a lot of extraneous stuff. And that's over. Always do that crooked. There we go. And that's over x minus 1. Okay. So this is basically a long division problem. So if you want to set it up the way that he set it up, and what he did was, there's nothing wrong with what he did. I mean, this is a common thing in algebra. And you would do a long division like this, and you say, okay, how many times is x go into x cubed? And you would say x squared. You'd multiply and you subtract. I could go through all that, but we're just kind of limited on our time right now. So let me just show you a little bit easier way. It's called synthetic division. This is kind of like x minus h, all right? So our h is a 1, right? It's not a negative 1, it's a 1. So what I'm going to do is this. Just bear with me. And I'm going to put a little box. This is what they usually do in synthetic division. It's kind of like this, except it's kind of flipped around a little bit, right? So if this is x minus 1, we just put a 1 right here, right? Instead of a negative 1. Now if it was x plus 1, what would you put right here? Put a negative 1, right? Okay, and what we're going to do here is we're just going to take the coefficients. You know what the coefficients are? They're the numbers that are out in front. And we're just going to list the coefficients out here like this. So what's the coefficient of my very first term? It's a 1. So I'm going to put a 1 right here. What's this coefficient? It's a 4, then negative 9, and then a 4. Okay, I'm not using all the x's and the cubes and the squareds and all that. That's why this makes it a little bit cleaner, a little bit quicker, a little bit easier, I think, to understand. And it's basically the rules of division. I'm not going to go through all the explanation. I'm just going to show you how to use this thing. Does this look familiar at all? Did you guys ever do this before? Some books teach it, some don't. What I'm going to do is take this 1 and I'm going to drop it down below this line. See, I left a little gap right here because I'm going to put some numbers in here. So I take this first number right here and I just drop it right here. Okay? And now watch what I'm going to do. This is kind of like what we do here, because when you stick a number up here, what do? You multiply them together, right? And then you subtract and all that kind of stuff. This time, what we're going to do is we're going to multiply this one times this one. So what's 1 times 1? It's 1, so I'm going to put it right here. Now, every time I put a number here, I'm going to add up these columns. I'm not going to subtract like we did in division. I'm going to add up these columns, all right? So I add up the column and I get a 5. And let's do the same routine all over again. It's kind of like long division, right? Where you do it one time, then you do kind of the same, you know, bring stuff down and you do it again, you bring stuff down and you do it again. It's kind of like that. So let's do the same thing. 1 times 5. Multiply 1 times 5 is 5. And you put it right there. Follow me? Now, what do you do with these? You add these up. It's negative 9 plus 5, which is negative 4. Okay, you do it again. What's the next step?
Or no, -1 times
Right, 1 times -4. You got it. 1 times -4 is -4, and you put it under here. You add these up. What do you get when you add those up? 0. So now, this right here is your remainder. You know how you had a remainder up here? The last one is your remainder. The next one, this number right here, I'll put a C for constant. That's just the number that's sitting there by itself, okay? So that's your constant. This right here is your x term, and this right here is your x squared term. Do you see how it goes in order? It goes x squared, then x, then the constant, then the remainder. So that's how I do that. So what's our answer then to this long division problem? Watch. This is our coefficient. It's our coefficient to the 1x squared. So what is that going to be? This is the 1 is the coefficient, and this is the part of the term. So it's just what? 1 x squared, right? Or just x squared. I don't need the 1 there, do I? What's this going to be right here? 5x. Now it's a positive, so what sign do we put here? Put a plus. Okay? So this is a positive 5x, we put plus 5x. Now this is a -4, so what do we put here? Minus 4. Now that's our constant. All right? Our constant is just a number that's by itself. It's not the x at all. And our remainder is 0, so we have no remainder. So look what we just did. We did this long division. We did it fairly simply without all the x's and all that kind of crazy stuff. All right? Got a little complicated when you do it by regular long division the way he was showing you. But this is a little bit easier. Is that one of our choices on number 11? Yep. Choice D. Yep. Is that the answer? Okay. Yep. Did that make any sense at all? All right.
Tons of sense.
All right.
What you thought I didn't even understand.
Yeah. So the long division thing, yeah, see, I hate how he does that, okay? There's a lot of things he does that I think are very good, okay? But I hate when he takes a minus and he makes it a plus, a negative. I think that makes it more confusing than anything, okay? I would rather just look at this. I know it's a plus, a negative 9x, okay? I'm fine with just saying minus 9x, aren't you? Yeah, and I think it's just putting too much stuff in there. He does that at first, and I noticed that later on he says, okay, well, we don't need the plus minus. Let's just make it minus 9x or whatever. Well, just do that in the beginning, you know? Just don't confuse me. And so I completely understand where you're coming from. Let's do number 12, okay? And if this was a normal class, I'd have you do it by yourself. But, again, we're short on time, so you can kind of do it with me here if you want. So it's x plus 3, big old division thing. And then it's negative 2x cubed. But let's do it with a synthetic division instead. Do you think you're going to like the synthetic better than the long division? Yeah, I think so. Now, there is a situation that it's a little bit more involved. If the coefficient of this x is not a 1, then you got to have to do something else, okay? So we'll see if they give you one like that. I'm not even sure if they give you one like that or not. But if the coefficient is not a 1, you're going to have to make it a 1 to do that synthetic division. The synthetic division only works when that coefficient is a 1. So how are we going to set this thing up? We put our little box thing, right? Negative 3, good, because you always put the opposite sign. And then what's my coefficients here? Yeah, negative 2. You got it. All right. Now watch this. You got to be careful though. Are all the basically are all the place values in here? We start off with an x cubed. So we have to have an x squared, and then the next thing has to be an x, and then the next thing has to be a constant. Sometimes they have an equation where it's not, where they leave it out. So what do you put in there? Plus 0x squared, right, or whatever the term that they leave out. So make sure you look at that, okay? If they do leave something out, you got to put the 0. It's kind of like filling in a place value, all right? And then, so what do we do here? Put a big old line. Again, leave some space because we're going to put some numbers here, right? And then what do we do first? Take that first number and just drop it down below the line. All right, so we don't do any multiplication or anything first. We just take that number and drop it below the line. You have done it? Okay, good. Now, we multiply and then we stick it in this spot right here. So that's going to be a positive 6. So I'll just put a positive 6 right here. And what do we do to these two columns? Or, yeah, this column right here, I should say. Yeah, just add them up. And so negative 5 plus 6 is a positive 1. Then you do it again. Negative 3 times 1 is negative 3. You add them up and you get a 5. See how nice and easy that is? Multiply them together, you get a negative 15, and you get a negative 8. So what is the negative 8? That's our what? Remainder. This is our constant. This is our x term, and this is our x squared term. So our answer would be negative 2x squared plus 1x, or just x, and then plus 5, and then our remainder is negative 8. Now what do we do with that negative 8? Right, we put it over whatever we're dividing by. Okay, so it's going to be minus 8 over x plus 3. Okay? Is that one of our choices? I hope so.
Looks like C. Yeah, that's it.
Is it C? Yeah, exactly. Yep, so that's C. Is that the answer? Is that the right answer? Okay. So that makes things a little bit easier for you, doesn't it? Would you agree? Yeah, you're going to have to use this long division to do those other problems. This is just the beginning of doing those more difficult problems on lesson 14. Do you remember the ones with the rational zero theorem and all that kind of stuff? Okay, it got a little bit complicated. So let's try one of those. Do you know? Yeah, that's the one I'm talking about. So like 18, 19, and 20, right? Tell you what, well, I don't think 18's all that bad. All right, let's do 18. 18's actually a lot easier than what it looks. It says find the zeros of the function. So here's the function, and it's x minus 2 cubed, and it's times x plus 4 to the 5th. So it's, oh, is it squared? Oh, it sure is, thank you. Alright, so what we're going to do is we're going to set this all equal to 0. Alright, so watch my fancy little program. I can just get rid of stuff and do that. Alright, so we set this equal to 0. Now, if, remember we talked about, was it last week we talked about if you have a product, if two things are being multiplied together and it equals 0, either one of these could be 0. Would you agree? So if I set this equal to 0, if this whole thing was 0, then 0 times anything, I don't care what that came out to be, that whole thing's going to equal 0. Follow me? If this right here was equal to 0, doesn't matter what this comes out to be, 0 times anything is going to be 0. So what I'm going to do is I'm going to set them both equal to 0. All right, so x minus 2 squared equals 0, and then x plus 4. So when you ever have that's basically what you're trying to get to. You're trying to get to a situation where you have a product, right? Two things that are being multiplied together, and it equals 0. So if you do this, if you solve, let me just take a quick peek. Now it's squared, so it's basically like this. Now I don't know why they list. It's weird how they list this answer. Since there's two of these things, let's do what I was going to do. If it was me, I would not list the answer the way they do. They do like this, okay? Would you agree that that's x minus 2 squared? Yeah, and then they take both of these and set it equal to 0, right? And then so what's x equal to? 2. And what's x equal to here? Well, they're the same number, right? In the answer key, right, in the book, they actually list them both, okay? They say x's or the zeros are 2 and 2. But why list the same number twice? I don't know. I don't get it. But that's what they do. So what do you think they do here then? What do you think? Yeah, they put -4 how many times? 5 times. Yeah, I'm not sure exactly what the reasoning. There might be a good reason for that. But anyway, that's what the reasoning is for that. Does that make sense why you get all those answers? Okay. Let's do another one. Let's do 19. 19's a little bit more. It's a little bit more involved. So we're finding the zeros. It says g of x. I'm just going to stick it equal to 0 right off the bat. There's 13x minus 6. And we're going to set this equal to 0. All right. All right. We'll see. We'll see how this one goes. I should have done this before. It's a little easier when the coefficient's just a 1 right here. But we have to find, remember, we're trying to find this. We're trying to do this, aren't we? That's what we're trying to get eventually. So in this first one, I want x minus something, call it h, all right? This is what I want. There was kind of a little trick to find what that number can be. Do you remember him doing that? I forget all the words for it. What did you call it? Called the, use some theorem, rational something, factor theorem. Yeah, it's probably called the factor theorem or something like that. Yeah, so well, theorem just means it's a rule, you know. I mean, that's all. Yeah, don't worry about. I'm not going to make you memorize them or anything. But let's take a look at this. So what could this possibly be? I want x minus something, right? And I can kind of figure out, because this has to make this whole thing a 0. Remember? Doesn't matter what's in here. If I can get this thing to be a 0, if I can get that number right there and plug it in for x and make that whole thing become a 0, then this is a factor, right, of this equation right here, or this expression right here. All right, so I got to figure out what that number is, and there was a way to do that. Sometimes it's a little time consuming, but remember he talked about that last term. That's the numerator. That's the factors of the numerator, right? And then the denominator. What are the factors of the denominator? It's the first one. It's that 2. Okay. So what are the factors of the numerator? It's 6. So what times what could give you 6? What are the possible factors of 6? Well, there's 1, right? Because there's 1 times 6, right? And what else is there? 2 times 3. Is there anything else that multiplies together to give you a 6? No, that's it, isn't there? I can't think of anything, can you? Right? 1 times 6, 2 times 3. Right? So those are some factors of 6. What about your denominator? It's 2, isn't it? So what times what can give you a 2? 1 times 2, and that's it, right? So these are your possible denominators. These are your possible numerators. And so what you're going to do is you're going to look. So let's start off with the first one. Let's take a 1. And you could also try the negative version of these as well, right? Because they do multiply to be -6, so you could try a positive and a negative. So what we could do is stick in a 1 and see if a 1 makes this thing into a 0. If it doesn't, try a -1. If that doesn't work, try a 2. If that doesn't work, try a -2. Are you with me? So sometimes it can be time consuming. Usually it's not the real big numbers. Right? Usually it's one of the smaller numbers when they give you these problems. So let's just try one. Let's try a 1. So this is 2 times 1, which is, so what I'm going to say try 1. All right? So I'm putting a 1 in for the x's and seeing if that thing comes out to be a 0. So let's see. Well, what's 1 cubed? It's 1. 1 times 2 is 2, isn't it? What's 1 squared? It's 1, so that's -1. Minus 13 times 1, so that's -13, minus 6. Does that come out to be a 0? No, that's not going to be a 0, is it? You see that? 2 minus 1 is 1, minus 13 is -12, minus 6. Nope, that doesn't work. Let's try a -1, all right? Let's try a -1 and throw that in here. So -1 cubed is -1 times 2 is -2. See what I'm doing? I'm just trying a bunch of numbers, okay, throwing them in here and seeing if it makes this thing come out to be a 0. If it comes out to be a 0, that's what I'm looking for, okay? That's what I want to find. Let's keep putting -1s in here. So -1 squared is 1, so this is going to be -1. This is a -1, which is a +13, and this is a -6. That's -3. Nope, that's not going to give you a 0, is it? So what else could we try? We could try a half, right? Because 1 over 2, we could try that. I wish I had it right now and I could tell you exactly which one to try, because I don't know if I want to sit here forever trying this. But sometimes you're going to have to do that. All right? I don't know if it's going to be a half or not. I don't know. Can I tell by the answer? Yeah, there's a possibility it could be. Well, let's try a 2. Let's just try a 2. It could be a 2 or it could be a half. All right? So let's put a 2 in for this. What's 2? 2 cubed is 8, right? And then times 2 is 16. Minus, put a 2 in for this. 2 squared is 4, so there's a 4. Put a 2 in for this. That's 26. That would be minus 26 and then minus 6. Does that come out to be 0? 16 minus 4, that's 12 minus that. Nah, that's not going to be a 0, so that doesn't work. Let's try negative 2. Negative 2 cubed is negative 8 times 2 is negative 16. Put a negative 2 in for this. It's still going to be a 4 because we square it, and that's going to be a negative 4. Let's put a negative 2 in for this. So that's going to be negative 13 times negative 2 is positive 26, and then minus 6. Let's see if that works. That's negative 20 plus 26, which is 6. And 6 minus 6 is what? 0. So, guess what worked? Negative 2 worked. So, what are we going to do? Why do we care that negative 2 works? Because we are going to use that as one of our factors. It's going to be x minus whatever this number is. So what is it? It's x minus, not 2, but x minus whatever this number is. What is this number? It's negative 2. So it's going to be x minus negative 2, which is the same thing as what? X plus 2. Okay, if you wanted to write that down, whoops. That's how we got that. All right, because it's always x minus h, or whatever letter you want to put in for that. Okay? We've only begun on this problem. All right, so watch. This is the outside factor. Remember, we're trying to find out what are the zeros? What makes this stuff multiply to be 0? Well, x plus 2 is one of them. All right? We got to figure out what's left inside of here. How do we do that? That means we have to factor out an x plus 2 from this whole thing right here. What do we mean by factor it out? We're actually dividing it out. Okay? Dividing. Does that ring a bell? That's what we did earlier, wasn't it? That long division stuff. So now what we have to do, let's get a different color here. Now what we have to do is we have to take that x plus 2 and divide it into this. So it's going to be x plus 2 out here, and then all this stuff inside of this. All right, so we have to do this division. We do this division. What the answer to this division goes where? The answer will go into this parentheses right here. Is it making any sense on what we're trying to do? All right, so what we're doing is we're factoring out an x plus 2 from this stuff right here. When I factor something out, it means I divide it. So I'm taking this stuff right here, dividing it by the x plus 2, find out what's left over, and that's going to go in this parentheses right here. Now we can do that synthetic division, can't we? Okay, on the video, he always did the long division thing. So what are we going to put in our little box here? Talk to me. A negative 2, right? Okay, and what's going to be out here? A 2, a negative 1, a negative 13, and a negative 6. Put our little bar, drop this thing down, and now we start that process. So that's negative 4. Add them up, that's negative 5. Multiply them, that's a 10. Add them up, it's a negative 3. Multiply them, it's a 6. Oh, that's a 0. So we have a remainder of 0, which is nice. I sure don't want an ugly remainder in here, because that would be really a mess, okay? They probably rig these, right, so it comes out real nice. So now we know what this is. This is our remainder, our constant, our x squared. So what's going to be in here now? 2x squared minus 5x minus 3. Okay? You with me so far? A lot of steps to this problem, aren't there? There's a ton. All right? So let me scooch this up a little bit. We're done with that part. Let's just stick with this thing right here. What we want to do is we want to find out what the zeros are. So we have a product now, don't we? So we take this and we set it equal to 0, so that's the easy part. X plus 2 is 0. And then we got to take this mess over here and set that equal to 0. This one's super easy. So what's x equal here? Negative 2, because we just subtracted 2. So that's one of our answers. Okay, but we're going to get 3 answers here. All right, that's just one of them. Now what we have to do is we have to solve for x here. Well, it may not factor really easy. It may and it may not. I can't really tell. I don't want to sit here all day trying to figure out if it factors. So what's a surefire method? And he talked about it on the video. What's a surefire method of solving for x when you have a quadratic? It's a big hint. When you have a quadratic, what formula would you use if you have a quadratic?
Oh, you plug your
Quadratic formula. Very good. See? Pretty big hints, right? All right. So we're going to use the quadratic formula. Do you guys, you know the quadratic formula, right? Okay. So he writes it on there. You can write it. I'm just going to stick it in right now. So x equals negative b. Now this is the a, this is the b, and this is the c. So it's negative b, or the opposite of b. So it's the opposite of negative 5, which is positive 5. Plus or minus, and then a big old square root. And then b squared. So it's negative 5 squared. Negative 5 times negative 5 is 25. And I'll just put it here. There's a few other steps you could have put in here, but I'm just, trying to. And then 4 times a. What's our a? It's 2 times our c. Remember, this is 4ac. What's the c? It's a negative 3. Right. Make sure you take the sign in front of it. And all that is over 2a, or 2 times what in this case? 2 times 2. And now we just simplify this. We're almost done. After how long? After 15 minutes of doing one problem? All right, we're almost finished. So it's 5 plus or minus the square root of, we'll go a little bit at a time here. I got a negative times a negative, which is going to be a positive. 4 times 2 is 8, times 3 is 24. Okay, over 2 times 2, which is 4. Let's simplify this a little bit. Let's work over this way. 5 plus or minus square root. This was nice of him, wasn't it? It kind of came out kind of nice, because 25 plus 24 is what? 49. Why was that nice? Because I can, yeah, exactly. I can take the square root of 49, which is 7, and that's over 4. Now we're not going to leave it like this, because we can simplify it. Remember, this is 2 things. Remember I said we're going to get 3 answers altogether? That's 1 answer. This is actually 2 answers. You understand that, right? This is going to be 5 plus 7 divided by 4. And what else is it going to be? 5 minus 7 divided by 4. Good. And so this is 12 divided by 4. What's 12 divided by 4? It's 3. So that's one of my answers. And what's this going to be? That's negative 2. I'll just write it. Negative 2 divided by 4. And what does that reduce to? Negative 1/2. Okay? And so those are your answers right there. It said find the zeros of the function. And so if you wanted to write it out nice and pretty, tell you what, we'll write it out in red so it stands out a little bit. So what are the zeros of that original function? It's negative 2. Let's go in order. You don't have to, but we'll go in order. Negative 1/2 and then positive 3. So that is the answer that they give. Whew, I'm worn out after that, aren't you?
I didn't get that problem. I didn't do anything like that.
So that's what he wants you to do, and I can't think of any other way to do that, to tell you the truth, besides that. So that's going to take some practice, all right? Yeah, it definitely makes things a little bit easier, doesn't it? That synthetic, it takes a real complicated problem, and it at least knocks off a little bit of the complicated part to it. But that's it. Okay, I'm not going to review it again. It's on here. By the way, Emily, I'm recording all the stuff that I'm doing, and I'm going to put it up on YouTube. And so if you want to go home this week and you watch this thing again, you can go to the YouTube page and watch it. Okay, and I'll show you how to get to it. I don't have internet in here, but I can at least give you the website and stuff like that, how to do it. All right, we've got 10 minutes tops. So do we have anything else? We spent all that time basically leading up to that one problem. But I think out of all the stuff that was on there, I think that was the hardest thing that you had to do. So I definitely wanted to hit that. All right, so we are going to do, let's see what color. Let's go to this deep blue, purple color. All right, so we're doing 14 from problem set 14. And it says if negative 3 and 4 are both zeros, okay, so these are zeros of the function. What did we just spend all that time doing? Finding out what the zeros were, right? This time they tell you what the zeros are, and you got to come up with the equation, basically, okay, or the function, whatever you want to call it. So basically it's like this. Your zeros are, remember I used H and K. I don't even know if they use H and K. I'm going to use H. Is that what they use? Okay, so here's the formula. This is a quadratic formula, basically. It's H minus K and H minus K. Or H minus, let me try this again, if I get my letters right. X minus H and X minus K. All right? Now, if you take a look at this, this would be considered either the h or the k, doesn't matter which one, and this would be considered the other one, right? So if this is h, then this one's the k. So if we set this up, what's it going to be? It's going to be h minus what? Negative 3, which eventually will be what? Right, plus. And it's times x minus, now this time is just a 4, right? So it's x minus a 4, and you set that equal to 0. Now, how do we change this into the function that they have listed in those choices? That's right, just use FOIL method and see what you get. So if we FOIL this, there's the first, there's the outside, there's the inside, and there's the last. And then we just simplify by adding like terms, and that's minus x, and that's minus 12, and that would be your function. Now they say, what was the function g of x? So if you want to be real particular, you can say g of x equals that right there. So it kind of went backwards, right? It was kind of like them giving you the answer, and we come up with a question. All right, is basically what that was. And if they started off with this, right, you could have factored it, right, and then set them equal to 0, and you would eventually got this these two numbers as zeros. All right, let's do this real quick. This is 1313, right? Number 13 from problem set 13. So it says that f of x is 3x, and then g of x is x squared over 3. And the question says, this is a composite function, but they want you to take the inverse of this. Okay? So what do we do first? We do this first, don't we? Work from the inside out. So we put a 3 into the g function. You could do it a couple ways, because this says the inverse, which means to take the reciprocal. So if I would do this, here's another way you could do this. So the inverse of this function would be what? Remember, the inverse is doing the reciprocal. It's just flipping the top and bottom. So what would the inverse of the g function be? Yeah, exactly. It would be 3 over x squared. Do you see that? And what is the inverse of the x function? What would that be? That would be 1 over 3x. Do you see that? So that's what you're putting them into. So that's probably a good way to do that, right? Just take the inverse of this, write it like that, take the inverse of that, write it like that, and then you can stick the numbers in. So this says put a 3 into the g function. So let's do that. Let's put the 3 into the g function, which means we're going to put it right here. So we put it, that 3's on top, and this is going to be 3 squared. That's 3 over 9, and what's 3 over 9? It's 1/3. See that? I already took the inverse right here, so I don't have to flip it again. So that's going to be 1/3. So now what we're doing is we're taking the inverse, we're taking 1/3, and we're putting it into the inverse of the f function. Here's the f function right here, so we're going to take this 1/3 and we're going to throw it into that. So it's going to be 1 over 3 times x, which is this 1/3 right here. Okay? So it's 1 over, what's 1/3 of 3? It's 1. 1 over 1 is 1, so the answer is 1. Got it? Alright, I think that's... I'm going to have to go because I have a class. As soon as I get back, the class starts, so I can't spend any more time. Plus, you got a class as well, too, don't you?
Yep.
Okay. Let me tell you how to get to the YouTube site, okay?